Hey guys, it's Mr. Zimmerman, and today we're going to talk about a new formula in E. So let's jump in, shall we? So we're going to go ahead and look at it. I just want to point out that with the outputs, we're going to look at for 1 year, for 5 years, and then we're going to go ahead and look at the difference if it's 530, 530, 90. So essentially what's happening in number 2 and number 3, this is just telling you how much your savings account would give you at the end of each year. And this formula does a really good job of that. But look at number 4 and 5. They're practically the same amount of money. You would think if it was being compounded monthly, it would skyrocket, and then weekly, 52 times, it would get even bigger. But it peaks out. It peaks out at about 530 and 90. So draw your attention to this table. If we do it quarterly, monthly, weekly, the amount that it's being multiplied by doesn't really change. And it approaches a number, just like the exponential function approached 0 but didn't quite hit it. It seems that when this formula, we've discovered an irrational number, E. The reason it's called E is because it's the irrational number came from exponents. Now, this is the second irrational number you should have encountered, the first one being pi. And essentially what it's saying is that if we are compounding it enough, it doesn't really matter. Now, it does mean that for year, I'm going to use compound interest. Compound interest is for the yearly formula. However, for anything more than that, we're actually going to use this formula, where A is the amount of money, R is the rate as a decimal, P is the principal, and T is the time in years. And I want you to compare and contrast these two formulas. Principal was the same, the rate and the time was the same. And let's just draw our attention to E. Essentially what E is E is this part. E is the R divided by K that's being added to 1. And since it approaches this number, I can just save some time and just use E instead, because it's only going to be a difference of cents. So this is our formula. We're going to use it for whenever a situation calls us to continuously compound something. Otherwise, we're going to use our other formula. Next time, we'll go ahead and look at a couple examples using this formula and remember it by using its name, PERT. All right, guys, this has been a blast. I will see you next time. Ciao.